We are asked to consider the graphs of a power function when it's written in the form f of x equals k times x raised to the a. And so what they want us to kind of observe is certain behavior. So if I say f of x is equal to 2x raised to the negative 3, what would that look like? What would f of x equals negative 0.4 x raised to the 1.5 look like? And what would f of x equals negative x raised to the 0.4? And so we'll see some different transformations, but basically any negative means that we're going to have x on the bottom, so x cannot equal 0 most of the time. So we'll get like this, we'll get like, I call it the Atari shape, but it's like it comes to 0 but never crosses 0. And sometimes it'll go down if you have a negative leading coefficient. When it's greater than 1, it does some interesting things. You should have the same number of humps, or one less number of humps than you do the power. So if you have a 4th degree polynomial, you can have 3 minimums or maximums in the function. You know, you're not always guaranteed to have 3 or 4, but you could. And this one is between 1 and 0, and so that'll give you that S-shaped thing, that 0.4. That'll give you kind of an S-shaped thing. So let's just graph all 3 of these and look and see. And basically the point of this exercise is to see or determine what happens when we change k and what happens when we change a. So we're going to say 2x raised to the negative 3. Whoops. Negative 3. Let's clear that out. So I graph it. Okay, so now I got like something like this, right? But notice it doesn't cross 0. In other words, x will not equal 0. Okay? Because really this is f of x is equal to 2 over x to the 3rd. Right? You guys know that? Alright, so now let's do the next one. I'm going to graph the second one. Now the negative is going to flip that upside down, and we're going to stretch it by a factor of 0.4, which means we're really going to compress it. And then it's raised to the 0.5. So what we are going to do is we're just going to come in here and change a few things. I'm going to say negative 0.4, whoops, negative 0.4 x raised to the 1.5, and then hit enter. Then I'm going to hit graph. Oh, that's different. Let me double check that, make sure that that's right. Negative 0.4 times x raised to the 1. Yeah, that's how it's supposed to look. So we get something like this. Okay. Now really what this is, and you'll find this interesting, this is really negative 0.4 times x to the 3. Isn't 1/2 the same as 3 over 2? So that's the square root of x cubed. That's weird, isn't it? So x can have a negative value, and we can't take the square root of a negative value, which is why when you look at the graph, we don't have anything that's negative, right? Notice Mr. Adams didn't draw his orange line past x equals 0. So x has to be either equal to or greater than 0 in this case. Alright, let's do the last one. Now for this one, it's probably going to have that S shape, but the S will be backwards, so it'll look like a Z. It should kind of go like this. So let's see. Oh wait, no, I'm wrong. That one will come up and down. So let's graph it and see. So because it flips because of the negative, so I'm going to say negative x raised to the 0.4. Now 0.4, here's the interesting thing about 0.4. 0.4 is 4 over 10, which is 2 over 5. So this is the same as negative times the 5th root of x squared. So that's interesting because whatever you square for x, it'll have like a positive value. So we should expect everything to be up on the top, but then this negative sign will flip it down. And so it should sort of look like this. Almost like an absolute value type function. Let's see. Yep. Any questions on that? So what we were supposed to do is just graph those and try to figure out what quadrants they'll live in, what they look like, what they're shaped like, and then do them in the graph. So for example, this one lived in quadrant 1, this one lived in quadrant 3, this one only lived in quadrant 4, and this one lived in quadrant 3, whoops, and quadrant 4. And what determined where it lived was basically the K and the A. Okay, that's it for